How are you doing today? My name is Seth, and I am working out of Volume 1 of Operation of Wastewater Treatment Plant, 8th edition. A little bit about myself. I am a Class 3 water and wastewater operator, and my purpose of this channel is just to go through these books. Maybe I can help you pass a test or prepare for a college exam. Um, but I just kind of wanted to go through chapter of the material. We will do a chapter in each book, volume one, volume two, and volume three. I'll kind of talk through these things. Feel free to listen to it in audio or watch it here on YouTube. So one of the main reasons on page one is why do we have wastewater treatment? Well, before the 1900s, a lot of cities would just dump their waste into the stream that was closest, which would carry it down to the next village or municipality. And that would obviously cause a huge public health uh, concern. And so diseases like cholera and dysentery um, just blossomed during those time periods. Um, and so into the 1900s, late 1800s, 1900s, we've really seen a concerted effort to try to treat the wastewater. You know, we want to remove those pathogens that can cause diseases from the wastewater. And one of our main goals, which is located on page three, is the protection of public health. Everybody uses uh, the creeks and the rivers for boating, fishing. A lot of communities um, get their drinking water from uh, from the rivers and streams and lakes. And so it becomes paramount that we treat the water. Um, I don't know if you know much about wastewater, but the water that normally you drink and the water that comes to your house goes through collection pipes to a sanitary sewer, then either goes um, to a sewage treatment plant. The sewage treatment plant processes the waste, cleans up the water, but normally discharges the water back to a river. So when we talk about sewage and those types of things, that's what we're talking about. You're like, why is canoeing and fishing? Well, most municipalities do release their um, treated wastewater into a creek or possibly um, a lake. But that's how the cycle works. So when we turn over, we want to talk about a couple things on wastewater components. So first off, you'll see on page four, you'll see the urban water cycle, and that explains uh, what I just tried to verbally talk about, where our drinking water runs to our homes, into municipalities, into factories. We use that. It goes down sewage pipes. We call the sewage pipe from your house. We call that a lateral, and that'll go into what we call a sewer main. And a sewer main takes many different laterals that are connected into it and will either gravity feed or will the sewer main will go into a pumping station. At the pumping station, we will pump it up and then it'll gravity feed back into the wastewater treatment plant. So the sewage gets conveyed um, from your house either by gravity or it goes by gravity into a pumping station. Then we pump it up to get the fall to go back into a into the plant. Because obviously, with some different terrains, like in Tennessee and Kentucky, your sewer plant may be here, and but there's a huge hill that blocks the path of it just to go gravity. And so that's why we do why we have lift stations. So when we talk about the collection system, normally what we have is organic waste, and organic waste are your food products. Um, anything that can break down. We usually call from vegetables, fruit, dairy, processing. Inorganics are your sand, your grit, basically things that don't break down readily in nature. And so um, that's our wastewater components. And you can, if you're following with me, it'd be on page 5. And a lot of that we have domestic contributions. And when we talk about the domestic contributions, that's it's coming from residential. And then we also have our like our factories and our schools, um, and some of our power plants and stuff like that. And so those are really the main contributors of wastewater. There's another major type of waste that do not fit in either the organic and inorganic. These are heated thermal waste and radioactive waste. We can get those from, like I said, power stations. We can also get those from hospitals, research laboratories, and nuclear power plants. And so those are the classifications that we kind of go with in the wastewater uh, industry. On the bottom of page 5, we'll talk about primary treatment. So, primary treatment, when you have a wastewater treatment facility, um, typically they are designed in several different fashions, but we're going to go over the typical um, treatment facility that you would see in your town. So, the waste comes in, we take out the rags, the grit, uh, we separate that. It then goes into a clarifier, and a clarifier is basically, if you can think about it, is a round swimming pool kind of thing, and the solids will settle to the bottom, and then the floatables will float to the top. When we talk about primary treatment, we're talking about that clarifier, or if you want to think of it as just a settling tank. That's in the beginning process. That's the after we remove the rags, the grit, and the grease, it goes into one of those tanks and it allows the solids to settle and the floatables to float. Usually, then we scrape off the bottom of those, and those will get fed to a digester. And we'll talk about that later on. When we talk about secondary treatment is usually a clarifier after um, usually after the aeration tank or trickling filter. And so that secondary treatment process is, and it is considered obviously with the aeration tank. But primary treatment, when we talk about that, usually it's just talking about a clarifier where we have that physical separation. Um, how do we treat wastewater? Um, well, we know that on page 6, we know that bacteria uses dissolved oxygen from the water and are called aerobic bacteria. When we put biodegradable matter down the drain, and let's say we would just discharge that to a river, that biodegradable material is actually going to take up oxygen in that river. As it degrades, bacteria is going to feast on it, and it's going to take up oxygen, and it's going to deplete the streams of oxygen. When this happens, you're going to have a fish kill, um, because the fish are competing with whatever um, bacteria or not bacteria, but um, biodegradable material that you're going to put into. And so you'll have this constant fight with the fish. And so that's why we want to treat the wastewater. We want to break down that biodegradable material so that when the water does get discharged to the creek, it's not um, consuming oxygen. So we've talked about um, aerobic bacteria. Aerobic bacteria basically uses oxygen, and that's when we're treating wastewater in our plant. Think of it as your stomach. We're trying to break down the material and properly treat it. And so when we do that, we're treating it with aerobic bacteria, bacteria that consumes oxygen, and we're also using anaerobic bacteria. Anaerobic bacteria breaks down the solids in the biodegradable material without oxygen. On the bottom of page 6, you'll see that major contagious diseases that could be spread by wastewater include Giardia, crypto, and other diseases may be spread through wastewater discharges include typhoid fever, cholera, dysentery, polio, and hepatitis. And so that is um, one of our main goals as a wastewater operator is to make sure that the receiving streams are properly disinfected, um, so that these do not cause problems down the road. Page 8, types of solids in wastewater. So there's total solids present in the wastewater. These include suspended and dissolved solids. And so you'll see that paragraph on bottom of page 8. So when we talk about total solids, we're talking about the ones, and you say suspended. On the laboratory, what we'll do is we will take a certain volume of water and we'll pass it along a white disc that looks like a piece of paper towel. We'll weigh out that little white disc. It's about the size of a $50. We'll weigh that out. We'll record the weight. We will pass through a vacuum flask. We will pass through our effluent water, perhaps, and on that white disc will trap any solids, and that's what we call total suspended solids. The clear water that goes through will actually collect in the bottom, and that'll be total dissolved solids. There's a couple steps we have to do with the white disc. We already weighed it out. Then we put the effluent through. We'll actually put that in an oven at 103 Celsius, let it dry for over an hour, and then we'll take it out and we'll weigh that pad on an analytical scale, and that will be our total suspended solids. It will be the measurement of the pad after we've added the effluent has properly strained through, and that will be our total suspended solids. Total dissolved solids are the when the water passes through that pad. So as you can tell, like it's going to catch any particulates on that pad, and so that pad's going to look dirty. Um, and that's our total suspended solids. What the clear water that passes through that pad, we will put in a flask. We will weigh that flask out. We will put that in an oven. It'll dry into a residue, and you guys have seen residue from like your washing machines and, from your dishwashers. It'll dry down to a residue, and we will weigh out that glassware and see how many dissolved solids are in there. So we can think about that as kind of like the calcium and magnesium. You can see that on your shower head uh, at your home. And so the suspended solids on page 9, the difference between settable and non-settable will depend on the size, the shape, and weight per unit. Um, so that's really what we're talking about in solids in our discussion. The Clean Water Act. As an operator, you need to know the Clean Water Act. This is on page 10. It was a large, sweeping act that really was used to clean up our waters. And that's where we kind of get some of our jurisdiction under. The NPDES permit. So each um, plant, like the plant I work at, it has a permit. It's a permit number. It's kind of like your social security number, and that is designated for your plant. And in that permit, there are several things that go into the permit, but with that, it tells you how much of a contaminant that you can actually discharge to, excuse me, to a creek, or what the pH level can be, or what the DO will be. On page 11, there's a number of NPDES permit program areas. We're not going to go over all of them, but there's a few I want to hit. Combined sewer overflows. A lot of when we talk about combined sewers, we're talking about sewers that handle stormwater and wastewater. Uh, and so, obviously, during huge storm events, that can overflow through the manholes and can cause problems in the city when we have that. So another one is sanitary sewer overflows. Obviously, we don't want those, but those do happen. There's a blockage. Um, if you have gravity feet of sewage and you have a blockage, it's going to come out at some point. And so, you know, we want to record that and send that to the EPA every time we have a sanitary sewer overflow or a combined sewer overflow. National Pretreatment Program. I believe that um, a lot of cities that have wastewater facilities that are over 5 million gallons per day, um, they'll have a national pretreatment program. They'll have a pretreatment program. Maybe it's a coordinator, and what he'll do is he will monitor industry, monitor what they're sending in terms of quantity and also quality of sewage. Because obviously, if you have a paper mill that is discharging a high BOD level, you don't want to charge them accordingly because you don't want to tax them at the same rate that a domestic user would. Biosolids. When we talk about biosolids, when we finally get done with the plant, when the water comes through, we end up with in an organic matter in some inorganic, but we end up with what we call sludge, and that sludge, um, we reduce the pathogens in such a way that we can use that as basically fertilizer. So at the end of the process, we have that material. We can land apply that, or it can go to a landfill. But farmers can use that for non-agricultural crops. Your main concern, bottom of 11, your main concern as an operator is the effluent limitations specified in your NPDES permit for your plant. Um, so they list some BOD, pH, oil and grease, most probable numbers of coliform group, bioassays, streamed bioassays. And so your permit that you have from your state or local government is going to tell you how many times you have to measure pH, DO a day. It's going to tell you how much BOD you can discharge to your receiving water or how what the pH can be. Going over to page 13, you can kind of look and these are the different contributors. That's a very good picture of the neighborhoods, processing, residential, office, hotels, and just have to know that, wastewater makes up, there's a lot of different contributors. Um, and knowing that and knowing what the typical characteristics of that discharge is going to be helpful because it's going to be different for the municipality or county or state. Obviously, a state park is not going to have um, it's going to be pretty traditional in its domestic makeup. However, it's going to vary a lot per season. In the winter months, most likely your state park is not going to have low, high flow. Sometimes your schools, once again, when they're in the summer, maybe you don't have low flow there. Manufacturing, maybe your manufacturer in your town or the county will have a cleaning process once a year and they'll dump down something that can adversely affect your wastewater plant. And so knowing these and monitoring these are important as a wastewater operator. Page 14, types of collection systems. We've talked about stormwater collection system and sanitary sewers. Page 15 is a good picture of what I'm talking about in terms of manholes and pumping stations. Um, our sanitary sewers, we want them to have a velocity of 2 feet per second. Um, Manholes, we want to place at 3 to 500 feet. The reason why we want that velocity of 2 feet per second is because the water needs to carry the solids. Any faster than that, the water will actually outrun the solids. And so let's think about a piece of toilet paper you flush down the toilet. That water needs to carry that piece of toilet paper all the way to the sewage plant. If the feet per second is too much, the water's going to outrun. Too low, and there's not going to be enough pressure to get that piece of toilet paper to the wastewater treatment plant. That's a picture of a force main on page 15. Um, Picture of two manholes. It's just a good thing. Why we put manholes in? Uh, because we need to have access to it. We need to be able to clean. We need to be able to vac. We need to be able to televise those lines, and we need to do that in a systematic way. And so having access to that where we get a jetter down there or a vac hose is paramount in our city. Uh, Page 16, we talk about preliminary treatment. Second paragraph. Preliminary treatment process is the screening, shredding, and grit removal. So after our lift stations and our gravity stations, we want to remove the grit from the eggshells, the coffee grounds, the rocks. We want to remove that um, from the wastewater before it gets into our plant. One thing we do pre-aeration is used to freshen the wastewater and helps remove fats, oils, and greases. We call that fog, fats, oils, and greases. So when restaurants, they're supposed to have a grease trap. A lot of times they don't. Some of that grease or from residentials will get down, and when it gets into the lift stations, it actually floats and pops to the top. And so it'll become like a mat, and that'll really cause problems with our sensors and our floats. Um, I've seen anything and everything flush down a toilet, especially on combined sewers. Um, so it's important that we have material or processes in place that we can take out anything as large as a 2x4 down to wipes. You know, these flushable wipes that we send, they're flushable, but they're not always pumpable. And so they become like a matted ball. And so that's why a lot of times you'll say, you know, you'll go into the stores and say, hey, in the bathrooms, it'll say, please don't flush flushable wipes because they do flush, um, but they're not always pumpable. And when they become, they'll coagulate into like a big ball and they can clog pumps and and other things of that nature. Page 17, that's a good picture of of a normal sewage treatment plant. So you have your influent comes in, you got to go to the bottom where it says influent and follow the arrows. So you go through the screen method where it removes roots, rags, and large debris. Then we remove the grit. The grit will fall out, and we usually lower less than 1.5 feet per second. Then we go to pre-aeration, freshen the wastewater, remove oils. Um, we get rid of some of that grease. Then we go through a flow meter. We'll go to our primary clarifier. The primary clarifier allows the fats, oils, and greases to float and the solids to settle to the bottom. Usually, you'll have a primary clarifier in a city that is bigger or has anaerobic digestion. So you don't absolutely have to have a primary clarifier, but it does help. Then in this particular plant, it will go into activated sludge. This is like your stomach. So the activated sludge is where we take a harvested biomass and we put it with influent that's coming in, and it treats the wastewater, removes the ammonia, removes nitrogen, phosphorus, and CBOD. Then after the activated sludge is the secondary clarifier. And after the secondary clarifier, that's where that biomass that we've developed in the activated sludge will settle out. And so it'll settle out to the bottom and we'll either pump it back to the head of the plant or we'll pump it to the solids handling purpose. But the clear water will come to the top and then the clear water will go to disinfection where we'll either add chlorine or UV and we will disinfect. And then obviously it'll go to its streaming stream. So the return activated sludge can either go to the head of the plant, but in that activated sludge chamber that you can see on page 17, the biomass can get so thick that it becomes inhibitory. And so we want to take, after a while, after that biomass gets so thick, we want to thin it down a little bit. And we'll actually send that to the solids handling. And we call that WAS. We call that waste activated sludge. So that'll go to a gravity thickener. We'll put it into either an anaerobic digester or a aerobic digester. When I talk about anaerobic, it doesn't have air. When we talk about aerobic, it does have air. We treat that, then we send it to a press, and that dewatering, we basically take that biomass, dewater it, and make it into a fertilizing clump, let's say. We'll load it up on trucks and we'll take that to the landfill, or we'll take it to farmers' fields so they can On page 18, when we talk about preliminary treatment, we talk about screening. So screening can uh, take all the wood, roots, rags, and we do a bar screen. So a bar screen is just a screen like this as the solids get onto it. In a smaller plant, then we would rake it up with just like a garden rake. And so a bar screen sets at like a 45-degree angle. The water goes through, and as the water goes through, um, it will trap onto the screen or onto the rack. I'm sorry, uh, or and it will be manually removed. A lot of plants, the bigger that it is, that manual is done away with, and we have some automated equipment. So we have shredding. Sometimes we shred the material with pumps. Um, but the grit chamber, what we do with the grit is we put it into a channel where we slow down the wastewater. You got to remember it's coming in from a 12-inch or 36-inch or 48-inch, but then we settle it down into a larger, you can almost say like a creek, and where it'll settle down and the grit will actually drop out. And so for that grit removal, we need it to drop out to about 1.5 feet per second. Um, go over flow measuring devices. Um, the partial flume, as in seen in page 21, is probably one of the most standard on the influent. But there's also the Venturi meter. But we want to measure that wastewater when we come in. One, because we need to know if we have a lot of I coming in, what we need to do to make sure that the water is adequately treated. Um, Maybe we need to speed up a process, slow down a process, but also we need to report that to the EPA. Primary treatment. You can see on page 23, that's what a clarifier looks like. And so the water will come in and it'll settle down to the bottom. And you can see that blade and the scrape and squeegee will go around and it will push the solids um, into the sump and then be pumped, usually to um, the head work or the sludge dewatering or the anaerobic digester. I'm sorry. Um, Either one. And then the scum will float to the top and we'll get that taken out by the scum trough. Generally, on page 23, the longer the detention time, the greater the solids removal. In a tank with a 2-hour detention time, approximately 60% of the suspended solids in raw wastewater will either be settled to the bottom or float to the surface. Uh, Removal of these solids will usually reduce the BOD of the waste. Um, when we talk about secondary treatment in many wastewater plants, the water flows from the primary clarifier into another unit, which receives secondary or biological treatment. This means that the wastewater is exposed to living organisms. So it's the uh, aeration tank. When we talk about activated sludge systems, we're talking about those systems where that biomass is put under air and we use it to treat. And so we have a tank, we have our mixed liquor suspended solids, we had our influent water come in, and it treats the the waste. Fixed film is like our trickling filters or rotating biological contractors, and we'll kind of go into those later on. Secondary clarifier. Secondary clarifier is usually after our aeration tanks or trickling filters, and that's just the final separation of the floatables and settables that are in our wastewater. Disinfection. So a lot of times with disinfection, we'll either use chlorine or we'll use UV to treat. UV comes in racks. Tertiary treatment on page 31. Tertiary is the final treatment that we do to try to remove any kind of leftover solids, and we'll talk about that more. I want to talk about the nitrification. Um, our whole thing is nitrification, denitrification. We try to take ammonia and we try to, by adding air and then adding less air and then adding air again, we're trying to get ammonia to go from ammonia to nitrate, and then to be released into the air as nitrogen gas. And so that's the nitrification, denitrification process. That's our main goal with trying to um, reduce ammonia in the wastewater. When we talk about enhanced on chapter one, enhanced suspended solids removal, usually we have flocculation, and usually um, it, it it follows coagulation and consists of gentle mixing of the wastewater. The purpose of the gentle or slow mixing, this is on page 32, is to produce larger and denser flock that will settle out rapidly. So, once again, we are trying to, with flocculation and coagulation and then detention, we're trying to get those solids that come into the wastewater system to coagulate. We may use a polymer, but we're trying to use a physical chemical reaction to settle those particles out. 33, membrane filtration. Um, we before we put the water to the creek, we'll use membrane filtration. You have micro, ultra, nano, and reverse osmosis. And you can see, micro is it allows some particles to go through. RO is your tightest wound membrane. And so sometimes at plants before discharge, we'll run them through an RO system. Lagoon systems. We also use lagoons. I think the first town I ever worked with had some antiquated lagoon systems, but lagoons are a great way to treat wastewater. Um, the problem is your footprint. So a town as big as like Phoenix, the lagoon system would be so huge that it's not it's not economical to do. But lagoons, so you have shallow lagoons, you have deep lagoons, um, just based off of what your design is. On page 37, you have your solids and handling. Um, in the bottom is a picture of an anaerobic digester. And so that's just talking about when we're talking about solids and disposal, we're talking about that, um, just that trying to get it to a dewatered, that biomass dewatered so that we can land apply. Um, in There's two types of bacteria that are present in the digester on page 38. The first group um, is called acid formers, and then the next group is called gas formers. So in your anaerobic digestion, you want to produce a gas because you can burn that off. And so a lot of wastewater plants, bigger towns you'll see, is they'll actually have a flame where they're burning off gas. And so you want to produce that gas, and you want it to be about 70% methane and 30% carbon dioxide is a good healthy anaerobic digester. And so an anaerobic digester you can see on page 39. Odor control, obviously, we want to control our odor. talk about different hazards. We'll talk about that later on. Um, but obviously, like a um, sampling program and all that. We will go into that later on. Well, I hope you enjoyed this video. I know that it can be kind of cumbersome. I hope as I do more of these that it will get better. But that is chapter one of uh, volume one of the water program Sacramento State issue. Thank you. Bye.